Okay, the next thing we're going to look at is something called position vectors, very briefly, because it's really easy stuff. Right, now a position vector is basically an indication of the movement in terms of direction and length of movement from one point to another. Let's say that we had a point A and a point B, and they were connected via this vector travelling from A to B. Now, if I said that this was the point -2, 5, and that this was the point 4, 6, well, what I could do then is form a position vector, which would give me the direction of travel and the amount of travel between A and B. So we can see then that to travel from A to B, you need to travel from -2 along to 4, so that would be a movement of 6. Okay, so that would be the horizontal component then. From -2 to 4 would be 6 in the positive direction, and then from 5 up to 6, that would be 1, so that vector would be 6, 1. Now, a quick way of getting it is that the position of B relative to A is going to be B minus A, so it's going to be the components of B minus the components of A. So AB will be 4, 6 minus A, which is -2, 5, and we're going to see that that's going to give us the exact same result. So 4 minus -2 is 6, and 6 minus 5 is 1, and it gives me the same result. Let's say that we had an example 2, and we had a point which was -4, -2, and a point Q which was 7, 11. Okay, so we're going to find the vector PQ. Okay, so the vector PQ, the position vector PQ, will be given by Q minus P. Okay, so the vector Q then is 7, 11 minus the vector P, which is -4, -2. 7 minus -4, 7 plus 4, that's 11, and 11 minus -2 is 13, so the vector this time would be 11, 13. Let's say that we had a point T, which was 3, 0, and a point V, which was -1, -6, and I want to get the vector TV, so that's going to be V minus T, so that's going to be 1, -6, -3, 0. -1 minus 3 is -4, and then -6 minus 0 is -6. Okay, let's try one more. Let's say that we've got a point A, which is -3, -1, and B, which is -1, 7. And then the question is to find the magnitude of the vector AB. Well, the first thing that we need to do is to find the column vector in itself, so that's going to be AB equals B minus A, and that's going to be -1, 7 minus A, which is -3, -1. Okay, -1 minus -3, that's -1 plus 3, that's 2, and then 7 minus -1, 7 plus 1, that's 8. I can now go about finding the magnitude. Okay, so that's going to be then the square root of 2 squared plus 8 squared. That's the square root of 4 plus 64, and that is the square root of 68. Okay, so the square root of 68, is that a surd which can be simplified? Well, let's just investigate this one a wee bit further. Let's get our square numbers down. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, now from that list, scrutinise that list closely. Is there any numbers up there that I can take? And I can take 4. Is there anything bigger? No, but I'm going to look for it, and I didn't find it, so let's go 4. How many times will 4 fit into 68? So that will be 17 times. So that's the square root of 4 times the square root of 17. Square root of 4 is 2, so the final answer then would be 2 root 17.